All right, today we're going to do the math practices and problem solving, lesson 3-7, critique reasoning. A group of 44 students is planning a train trip to Washington, D.C. They held many fundraisers and raised $10,880. Nathan said we should have enough money to pay for the train tickets. There are about 50 students going on the trip, and one round trip ticket cost about $200. That makes the total cost of the tickets less than $10,000. Does Nathan's reasoning make sense? So let's see what we have here. A round trip ticket means a ticket that goes from the start point to the destination and back to the start point again. So is it reasonable that the ticket costs $200? Let's check on that first. So here's the cost. It's $92 in one direction and $92 in the other direction, which totals $184. He's rounding that to 200. It's an overestimate, which is good when you're dealing with money. You don't want to have not enough money. So I would say $200 is reasonable. And he's got 50 students. So my equation would be 50 times 200. Oops, 200. Solving a simple problem, 5 times 2 is 10. We're going to bring 3 zeros over. So is that reasonable? Yes, it is reasonable. So you can say his answer is reasonable. So all we're going to do is be checking other people's work in this lesson. So you'll have to solve the problem to make sure their thought process is reasonable. It's a really good life math lesson. What argument would I make to support Nathan's estimate? And we just kind of went over that. So you can put that in your own words if you're doing the bookwork. How can you critique reasoning of others? So that's looking at other people's work and seeing if it makes sense. In this problem here, you're going to have to ask questions for clarification, decide if the strategy makes sense, and look for flaws in estimates or calculations. So you kind of have to solve the problem yourself and make sure it matches up with what the person used for their problem solving. Ms. Lynch needs to ship 89 boxes. 47 boxes weigh 150 pounds each. Each of the other boxes weighs 210 pounds. Mia says that 89 boxes can fit into one container. She reasons that 47 times 150 is less than 7,000, and 42 times 210 is a little more than 8,000. So the sum of their weights should be less than 15,400. Was her reasoning? What is Mia's reasoning to support her estimate? Mia estimates the total number of the lighter boxes and the total number of the heavier boxes, then adds the two estimates. So let's see what the problem is with her reasoning here. Mia's reasoning has flaws. She estimated 42 times 210 is a little more than 2,000, but a better estimate would be 9,000. And remember, if she's going to get 8,000, that means she just, instead, when she had 42 times 210, she rounded down to 40 times 200 to get 8,000. You can't, if she gets 8,000, it's an underestimate, and she's not going to be able to fit everything. Her conclusion is not valid. It's too far under. You need to make an overestimate to make sure everything is going to fit in. The weight of the heavier boxes is 8,820 pounds. The weight of the lighter boxes is 7,050 pounds. So the total weight is 15,870 pounds. The sum is greater than 15,400. So her reasoning does not make sense because of the first part of her problem being too low. Her estimate is too low. So that's just kind of looking through to see where the people are, where the thought process is right or where it's wrong. That's all you're doing today. Raul says that one way to get the cargo under the weight limit is to remove two of the heavier boxes and one of the lighter boxes. How can you decide if Raul's reasoning makes sense? So does that make sense to be removing boxes and to get everything to fit? Nathan's estimate, since Nathan estimated the total, wrong one. Since the sample answer would be like, let's see, if you had 15,870, which is the total weight, the actual weight. If you took out 2 of the bigger boxes and 1 of the smaller boxes, you would get 15,300, and his reasoning would make sense. So that's kind of how you would frame that problem out. So we're just checking to see if the person's thought process makes sense or not. And we just have a couple problems to do. A stadium has 58 sections of seats. There are 288 seats in each section. Mary estimated the total number of seats by multiplying 60 times 300. She concludes the stadium has fewer than 18,000 seats. What is Mary's argument and how does she support it? So she's saying the stadium has fewer than 18,000 seats is her argument. That's what she's saying. And how can we support that? So what she did was she said there's 288 seats and 58 sections. She decided to go with 300 times 60. And she did an overestimate. So she's saying when she overestimates, she gets 18,000. So her reasoning is that there's less than 18,000 seats, and that's correct because her estimate is an overestimate. It's more than the actual number of seats because she rounded up on 288 and she rounded up on 58. Describe at least one thing you would do to critique Mary's reasoning. Well, of course, you're always going to check their work. You're going to check the math. That's always the best way to get started when you're looking to see if somebody did something correct. And does the math make sense? Does Mary's conclusion make sense? Yeah, her answer works because she underestimated. Mary used compatible numbers. Actually, in this case, you technically could say she estimated. Just all old school estimated. Mary used estimated numbers that were less than the actual numbers. Than the actual values. So she gets an overestimate. So that's what you would write in there. So you're looking and double checking somebody else's math. And that's all you're doing today. It's, a little tricky. You got to focus. Make sure you are in a quiet place so you can think these through and do your best.